The following is a short presentation on linear regression analysis. If you'll remember from our analysis of cost behavior and cost volume profit analysis, we classified cost into three major categories. The first one being variable cost, where total costs vary directly with volume. Fixed cost, where costs remain the same no matter what volume level exists. And lastly, we have a mixed cost, which contains the characteristics of both a variable cost and a fixed cost. So with mixed cost, one of the common uses of linear regression analysis is the estimation of the fixed and variable components for mixed costs. Now, with linear regression analysis, we're creating an equation that expresses the relationship between two variables, and we call this single regression analysis, where we have an independent variable, and based upon what that independent variable does, we have a dependent variable which changes based upon the changes in the independent variable. Now, if we were to take a look at and plot some cost volume relationships, here we can see a situation where as volume increases, generally speaking, we're also seeing our costs also increase. Now, what we have to be able to do in order to predict future costs beyond these points here, or between these points, is come up with some type of relationship between our fixed costs and our variable cost. You'll notice total cost is our dependent variable and volume is our independent variable. What we want to be able to do is create some form of equation, in this case a linear equation, that provides a reasonable prediction of what our total costs are going to be at any particular volume. Now you'll notice these are not necessarily a perfect relationship because they do have variability, but we have to come up with something that will be a good approximation and hopefully minimize the amount of variability between our dependent and independent variables. Now, the actual linear equation itself comes out to y equals a plus b times x. And that looks kind of complicated, but again, we'll see when we boil it down, it's not as bad as it looks. Okay, now y is the dependent variable. That represents the total cost of the mixed costs. A is what we call the y-intercept. That is basically the fixed portion of the mixed cost. B is the slope of the regression line. In other words, the variable portion of our mixed cost. And X is, of course, the independent variable. In this case, that would be volume. Okay, Okay, let's go back and revisit the linear regression formula, y equals a plus bx, and the various variables that define the equation. Okay, if you are given a question or questions on the CPA exam about linear regression, you should know that you will be expected to know this formula as it is and the meaning of all the linear regression components. It would be nice if we just labeled y as a dependent variable and a the y-intercept and so forth, but that's not the way they do it. It's going to be y equals a plus bx. So kind of commit the, not kind of, but commit the linear regression analysis formula in memory and the components. Now, in addition, there's one other element of the formula that's going to be very important, and it's called R2 or R squared. It's called the coefficient of determination. Kind of a fancy word, coefficient of determination, but what it is, it's very important because it expresses the strength of the correlation between the dependent and independent variables. So you can determine some form of statistical measure about how reliable is the correlation, that linear regression formula that you've developed, how reliable is that in predicting your future mixed costs at different volumes. Now, R2 or R squared is between the values typically of 0 and 1. The closer R2 is to the value of 1, the greater the correlation between the dependent and independent variables. The closer it is to 0, the less the correlation exists between the dependent independent variables. Now, you should also know that there can be what we call negative correlations, where a correlation of a -1 means that the two variables move in perfect inverse correlation. Now, let's take a look at an example. A company had plotted its mixed cost at various levels using a regression analysis program, and we get the following results. The number 700,000, and later on we'll translate that to dollars, then the number 40, which will be $40, and R squared, which is 0.8. So here's how we would interpret that information. Okay, the program results indicate the intercept, which is A. Okay, in other words, a fixed cost occur at $700,000. We also know that variable costs are estimated at $40 per unit. That's B, the slope. And then R squared. R squared says that R squared indicates basically of 0.8, its usefulness in predicting the correlation between the dependent and the independent variable. Now, if you want to come up with the percentage of correlation, you could simply take R and square it. So what happens is if we take R squared, if we do that, it's 0.8 times 0.8. That means that 64% of the variation in our variable cost, in other words, B, can be explained by the change in volume. Okay, with that, let's go to some of the linear regression questions. Number 1, in regression analysis, which correlation coefficient represents the strongest relationship between an independent and dependent variable? Okay, be careful because I say represents the strongest relationship. So go ahead, stop the video, determine the correct answer, and when you're ready, please restart your video. The answer to question 1. Number 1 is kind of a trick question. The answer to question number 1 is B, which is a -0.9. And I have a lot of information explaining regression analysis in the answer here, but the actual answer to the question is in the the red circled portion. And it says in the case of answer A, 0.75 is not as close to 1.0 as is D with the value of 0.8. C is not correct because the correlation cannot go beyond 1.0 or a negative 1.0. Now, here's where the trick part is. Remember that the question is asking for the strongest relationship. It's not saying positive or negative, or a positive or an inverse relationship. Okay, so in this case, 0.90 is closer to a perfect inverse relationship of negative 1.0 than D, basically with the value of 0.8, which with its perfect correlation would be 1.0. So that's the answer to number 1. Okay, let's look at question number 2. Company A wants to determine the most meaningful method of allocating factory maintenance cost to production. 2 cost drivers have been identified. Using regression analysis, the company develops the following data. Machine hours, the y-intercept coefficient is 3,000. The B coefficient is 3 and the R squared is 0.6. In the case of machine setup time, the y-intercept coefficient is 1,200, the B coefficient is 4.5, and the R squared is 0.55. So which of the following regression equations should be used? Again, go ahead, review the equation, stop your video, and you're ready, restart your video. Okay, the answer to number 2 is A, where y equals 3,000 plus 3 times x. Now, you're not normally going to be required to perform regression analysis because that requires specialized computations or a program. But again, you're going to be required to know the components of that regression analysis formula and how they are going to be applied. So again, remember, you're going to have to memorize the regression computation. Remember that y is the dependent variable. Usually in the exam, it's probably overhead cost. A is the intersect point for the overhead cost you are examining, and B is the slope of the line of the independent variable, in effect the cost driver, and X is the independent variable. Or again, I show y equals A plus BX. Now in this problem, you need to select the cost driver with the most meaningful relationship. Now sometimes the exam will use the term correlation coefficient. Other times the exam may use the regression formula called R squared. It means the same thing, or R2. You'll be expected to know both of those terms. So in this case, the most appropriate formula in terms of relationships would be the R squared, where it's 0.6. So the answer would be to use all the regression data associated with the result where the answer is basically associated with 0.6. So in that case, the answer would be A, y equals 3,000 plus 3.0 times x. Okay, number 3. After running a regression analysis for machine maintenance expense, the following was derived for labor hours. B equals 7, A equals 6,000, R squared equals 0.88, SB equals 60. If 500 machine hours are incurred, what would the company expect as machine maintenance expense? You're given a number of choices. Go ahead and do your computations. Don't forget to stop the video. When you're ready, restart your video. Okay, number 3. If 500 labor hours are incurred, what would the company expect as a machine maintenance expense? And the answer in this case is D, $9,500. Now, here's the key to this problem. Don't get distracted by additional information entered in the equation. Okay, in this problem, you have to sort out the relevant information. You do this by remembering the regression formula again. y equals a plus b times x. And all you have to do is substitute the relevant values from the problem, and you'll notice SB is never a factor in the equation, so you don't even have to worry about that. So that's the answer to question number 3. Question number 4. After running a number of regression analyses for preventive maintenance of automated production machinery, no meaningful correlation was noted between any cost drivers and preventive maintenance costs. So they weren't able to come up with anything statistically. The cost accounting department then decided to call the factory supervisors together to discuss and arrive at a consensus of the most meaningful allocation of overhead preventive maintenance cost. Now, this is an analysis method, and it's one of these 4 methods. And again, if you don't know, take your best guess. This is a learning slide. So again, go ahead, stop the video, do your analysis, and then when you're ready, please restart your video. Okay, the answer to number 4 is where the accounting department calls together the factory supervisors to discuss and arrive at a consensus of the most meaningful allocation of preventive maintenance costs. And the answer in this case is called the Delphi method. And if you got it wrong, that's okay, because you were probably guessing as to the answer, so you're here to learn. The Delphi method is a forecasting method based upon the results of questionnaires or some other type of either emails or discussion groups or whatever. And basically it involves a panel of experts, and these happen to be, the experts in this case happen to be the factory supervisors who knew a lot about preventive maintenance costs. Typically several rounds of questionnaires or discussions, questionnaires are sent out, or discussions are made, and basically anonymous responses then are aggregated and shared with the group after each round. And then the experts, after they review all the results, are permitted to go ahead and adjust their answers in subsequent rounds, with the goal eventually of achieving some form of acceptable or correct response through a form of consensus. So with that learning slide, that is the last slide in the linear regression presentation. Thank you so much for your time.